Now let's take a look at example 3.2a. This question here involves two forces. So what we need to do is resolve one force at a time. First, let's resolve the 40 Newton into the x as well as the y component. So for the x component, it will be here. So this will be my fx. For the y component, it will be here. Okay, remember vector, you have to join head to tail. So I shift my fy here. And the angle given is 30. So instead of shifting my fy or fx below, or leave it below, I can actually shift it up here. Or if you like, you can complete the parallelogram. Okay, so from here, the angle given is 30. I want to find the x component, which is opposite. I have the hypotenuse, so I should be using so. So your fx will be 40 sine 35 or sine 30. Okay, then do the same thing for fy. Fy will be here. This one here is parallel to this. So these two have the same length. So my fy will be adjacent over hypo. So that is car. So fy will be 40 cosine 30. Okay, now let's take a look at the 50 Newton. Okay, so you're going to do the same thing. The angle is given here. So I can draw my fx here and then the fy here. So the fy will be opposite of the angle. Opposite and hypo will give you so. So the fy will be sine. Then the fx will be adjacent over hypo. So that will be cosine. So fy will be 50 sine 25. Fx will be 50 cosine 25. Okay, but that's not the end, because we actually have two forces that are in x direction. Okay, here, this one and this one. We also have two forces that are in the y direction, namely this and this. So what we need to do now is to find the resultant force in the x and the y direction. So the total force in the y direction, we can now just add them because both are in the same direction. Both are pointing upwards. So the resultant force in the y direction, okay, the total force in the y direction will be 55.8 Newton. Then do the same thing for the x direction. So the total force in the x direction will be the sum of these two forces here. That will give me a total of 65.3 Newton. Okay, let's take a look at 3.2b. Same thing, I have to find the resultant, or rather the total force acting in the x and y direction. So you have to resolve your 40 Newton into x and y direction. So using your trigo function, you should end up with fy to be 40 cosine 30. Fx will be 40 sine 30. Okay, that is for one force. Then there's another force, which is the 50 Newton acting at an angle 25 degree below the horizontal. So I have to resolve it. My fy now will be negative because force is a vector. So if I take upward to be positive, then downward will be negative. Notice that your 50 Newton, when you resolve it, the vertical component is actually here. So this is your fy for the 50 Newton. So pointing down, that's why you need a negative sign. Okay, then similarly, if you were to take a look at the x component, it's going in the negative x direction. So there will be a negative sign also. That is to say, I'm taking the sign convention. For x-axis, follow your xy axis in math. Going to the right, that is positive. Then y-axis, going up is positive. So the total force in the y direction will be the positive minus the negative, and you end up with 13.5 Newton. So your force in the y direction will be 13.5 Newton upwards because you end up with a positive sign. Then for the x direction, okay, the two vectors are in opposite direction, so you have to subtract, take care of the negative sign, and you end up with minus 25.3 Newton. That is to say, the total force in the x direction is actually acting to the left, and with a magnitude of 25.3 Newton. Okay, we move on to 3.2c. In 3.2c, again there are two forces. Okay, I will do the 50 Newton first, since the answer is already here. For the 50 Newton, very easy. It is only acting in the x direction, but negative x direction. So same thing, we follow the math. To the right is positive for x, going upward is positive for y. So your Fx will be negative 50 Newton and Fy will be 0 because there is no component in the y direction. Then for the 40 Newton, okay, same thing. If I were to find the vertical component, which is here, and the horizontal component, which is here, because the angle given is here, so what we can do is complete the parallelogram. So this is my Fx and this will be my Fy. So using trigo function, here Fx, which is opposite, so it will be your SO. So Fx will be the hypotenuse, which is the resultant force here, 40 sine 30. Then your Fy, which is the adjacent, will be cosine. So you end up with 40 cosine 30. Okay, so both are in the positive direction. So the total force in the y direction will be just 40 cos 30 minus 0. So it's still 40 cos 30. And that will give me a magnitude of 34.6. The total force in the x direction will be 40 sine 30 minus 50. So that will give you an answer of minus 30 Newton. So the resultant force in the x direction is actually 30 Newton to the left. Okay, we come to the last example, example 3.2d. So here, do the same thing. We do one force at a time. For the 40 Newton, okay, we have to resolve it. This is the y component, this is the x component. Okay, since the angle is given here, so you can complete your parallelogram. So this is your Fy, this is your Fx. Okay, or some of you might like to use this angle. You can work out this angle as 60. Then you can use this triangle. Okay, so if I use the angle 30, I will end up with 40 cosine 30 for Fy. Fx, which is the opposite, will be 40 sine 30. But if I use the angle 60, right? Okay, I can also use this angle 60. Can you see that Fy now is your opposite? Okay, this is opposite. 40 Newton is the hypotenuse. So opposite and hypotenuse, that will give me sine. Then I'll end up with sine 60 equals to Fy over hypotenuse, which is 40. So my Fy will be equals to 40 sine 60. Okay, if you press the calculator, you see that 40 sine 60 is the same as what we get up here, right? 40 cosine 30. So you can press the calculator. These two are actually the same. Okay, so whether you want to use the angle 60 or 30, it doesn't matter. Just make sure that you use the trigo function correctly. Okay, next we have the 40 Newton, the green one. Notice that it's only in the horizontal direction. So Fy will be 0. Fx will be negative 40 because it's towards the left. And finally, the 40 Newton, which is at the angle 60 below the horizontal. So resolve into the x and y direction. The Fy will be negative because it's pointing down. So that will be 40 sine 60. And Fx will be positive. So that is 40 cosine 60. So same thing, total force in the y direction. So add all the y direction, you should end up with 0 Newton. Okay, find the total force in the x direction. So add up everything, again is 0 Newton. Okay, so what can you say about the total force acting on this object? It's actually 0. So we say that this system is in equilibrium. Okay, so we stop here.